Hello, Professor. My name is Abdulgafar Tolawi with student ID 101462578. I'll be talking about this project, and this project is focused on predicting house price for cargoes competition. I use essential libraries for data handling and SG. I use the SG boost for machine learning and processing, and I use Spicy for parameter tuning. And this is the outcome. Once this was run, it's gonna give me my student ID and whatever it's gonna show me here. And yeah, I loaded the training and test data set from their respective file paths. The training data include house features and their correspondent that I already did from the cargo for me to get the CSV file from there. So the training data includes house features and their corresponding sales price, while the test data only contains house features. The training data has a shape of rows, columns, and the test data has a shape which was calculated when I tried to run the code. And for the SX3, I separated the target variable sale price and the log transferred. It normalized the distribution, the ID column, which is not useful for prediction. The result features data set as a shape of rows and column. This is the target variable separated, and this is the ID column features shape, and that's it. So once the code was run, it's going to give me my data set and colon and whatever. Yeah. So for this, I removed the colon. The colon was removed with more than 10% missing values as they could negatively impact the model. The same colon were dropped from the data sets to maintain consistency. And this is it. Once this code was run, it's going to give me some consistency about what I was doing on my data set. So categorically, features were converted to numeric values using label encoder for the test data set. I handled unseen labels by assigning them a placeholder value. So I just did this anyways. I don't think it was needed. So missing values in numerical columns were filled as well. I split the data into 80% and 20% validation set. The training set is used to train the model, and the validation set helps evaluate its performance. So for this part, so I use the randomized search CV to tune the hyperparameters of the XGBoost model, which speeds up training while the maintaining accuracy. For this part, it's just used to define my part here, which is this, and this one was used by the best model identified by the randomized CV was trained on the full training database. And the prediction and evaluate the model widespread best and SGP predicts equal the uncoded value for validation for RMSE. This is the RMSE that was did for it to get validation. And I did the index, the prediction, and I did the index text, which the submission frame for it, and I did the submission which was created. Then the submission file was this, and was created, then I did this to do the series for it to be submitting so that I will be able to submit it on Kaggle as it was instructed by the professor. Thank you.